So let's start. So once the problem's all written out and all the units are in and everything, we're gonna notice that right here the problem is asking us to determine the max tensile and compressive stresses in the beam. So we know we're going to be using our bending stresses equation. And first thing I notice is the number of axes of symmetry in our cross section. And we know we have one going up, but that is it. So we know that we're going to be looking for a centroid. So we know that the centroid is going to be closer to this top, heavier part of the beam because that's where our neutral axis it's going to be located in a section that's obviously not in the center because it's top heavy. So we know we're going to do a centroid calculation, and I'm going to pick a point based off of the bottom just because it's natural to have a positive x going up and a negative x as a or y bar for our dimensions. I'm assuming the centroid is going to be around here, closer to the top, as I said, and our initial centroid equations are basically just finding the centroid, and we're dividing this up into 3 parts. And these equations are on my equation sheet if you would like to look at them for a refresher. So our centroid is located 4.7 inches from the bottom. And now with this location, we can based off of this, we can find our I values, and then we have a neutral axis in which all of our equations are based off of. So now we're going to find our I for this, and we're going to be using the parallel axis theorem because we have 3 sections and each one is a rectangle, and we only know the equation for I of a rectangle plus semicircle, triangle, and all the other ones that are also on that additional sheet I provided. Most of them are rectangles. The I calculations are pretty straightforward. Make sure you type them in the calculator correctly. But since we are summing all of the sections, we are finding this distance to the centroid for each one. So for section 1, we will be taking this center part and then referring it back to our centroid and then squaring it. Once we have our I, we make sure that we're in the correct units. This is a good time to point out that all the units are written on here, and it's a good habit to follow through the units to make sure that it's all making sense. Having an I inches to the 4th is what we're looking for our I numbers. We do notice that in our moment we have kip inches. So kips, which is not our base unit, but regular pounds aren't asked for in this problem. So to find the moment, we can do a shear and moment diagram and then figure out what the moment is in section BC, which is what we're looking for. Simple calculation will give us about 500 kip inches, and this is in this entire section. We see this is a positive number because we know that the beam is going to be smiling. It's going to be there's vertical load on this beam causing a positive number. So we know that this number is at least on the right side of the positive or negative. Now it seems that we have most of our information to put it all into our bending stress equation. And so our bending stress equation, negative mc over I, c being the distance to the topmost fiber of our beam in both sides. So we want the max tensile and compressive stresses. So just by observation, we know that the maximum compressive stresses are going to be on our top portion of the beam, and the max tensile stresses should be in the bottom of our beam, just by observing how the beam is going to bend. So our 2 equations for top and bottom, we have C top and our C bottom, and we're using the moment in the section BC. Make sure we write kip inches because that is what we were given here. Units are important. And for the flange in the bottom, because of our notation here, and we denoted that Y bar going up as positive and anything going to the negative direction would be in fact negative, we have to write a negative 4.7 inches to this bottom flange. Which makes sense because these two negatives in our equation would cancel out, so we would get a positive, we should get a positive number for tension, and that's how our notation is, and most of our books are based off of tension being positive. That's what the negative sign is, and it makes sense that we have opposite signs for these two, matching our convention here.